Here is a third technique. So don't think of there being a progression here. Okay, so these are all independent sort of modular techniques that you can mix and match um, any way you like. Okay, so it's a set of techniques. So the third technique for narrowing down the candidates to a smaller set is using what are called as champion lists. Now these champion lists are computed at the time we build the index. And what is a champion list? For every dictionary term, the champion list will contain the top R documents which have the highest weight, the highest TF-IDF weight in the postings list for T. Okay, recall that the postings in the postings list for T are sorted in order of increasing doc ID. But they also have TF-IDF weights, right? And those documents in the postings list which have a high TF-IDF weight are probably going to contribute more to the overall query than documents which have a small TF-IDF weight. So why not pick the top R documents in the postings list which have the highest TF-IDF weight among all the documents in that postings list and store them in a champion list for that term. Sometimes it's called a champion list, sometimes it's called a fancy list, sometimes it's called the top documents for T. Okay, all three phrases are used. And this champion list is prepared for every term at the time we build the index. Okay, at the time we actually compute the TF-IDF weights, or at least the TF weights. Now, theoretically, it is possible that the length of the champion list could be less than the number of, well, before we look at this, how do we use the champion list? When we try to answer a query, we are instead of focusing on every document in the postings list for the terms that appear in the query, let's only focus on the documents in the champion list of of at least one of the terms in the query. Okay, that means instead of computing scores for every document in the postings list, we are going to compute scores only for those documents that appear in the champion list of some query term. Right, to give an example, okay, let me take the example here. Okay, let's say T1 has 100 documents in its postings list. T2 has 500. Okay, and T3 has 300. Suppose we decide that our champion list is going to contain the top 20 documents for each term in terms of their TF-IDF weights. So we'll have a small champion list for T1, a small champion list for T2, and a small champion list for T3. Okay, conceptually, you can mark the documents that appear in a champion list in different ways. Maybe you can just have an extra field here telling us whether or not this particular doc ID belongs to the champion list for this term or not. You can store the members of the champion list by marking them as members within the postings list itself. But however you implement a champion list, what we will do is when we are doing this pointer walkthrough in these three lists, before we do the cosine computation for the current document that we are looking at, we are going to check whether the current document is marked as a champion in at least one of the three lists. Okay, of course, if the document appears in only one of the lists, then it has to be marked as champion in that list. If it appears in two of the lists, it has to be marked as champion in either of the two lists. If it appears in all three of these lists, it has to be marked as champion in at least one of the three lists. So as long as a document is marked a champion, then we will do the cosine score computation for that document. If a document is not marked as champion in any of the three lists, we're just going to ignore it and move on further in the walkthrough. So that means the cosine score computation is being done on a smaller set, not on all j of the documents that appear in the three postings list, but only for a subset of them which are marked as champion. And once the scores are computed for those documents, then we pick the top k of them. Now, since the champion list is something chosen at index build time, we have to fix the length of the champion list in advance, right? So what happens if we choose a value of k? Okay, we want the top 100 documents, but a champion list has only 20 of them. Okay, and even if we take the union of the champion lists in all three of these lists, let's say there are only about 75 documents in these three postings lists which are marked as champion in at least one of the lists. And we want the top 100 out of those 75. So that's going to be a simple degenerate case. Right? So in theory, it's possible that we could end up requiring more than what we could require k documents, but k ends up being larger than the size of the set A. And the way to deal with this is something we're going to look at a few minutes later. Okay, in general, you don't have a single index. You generally have a combination of them, and you do the fastest possible computation. And if you still need more results, then you go to a different index which is using a less optimal uh, technique for computing the rankings. And again, think about how this idea of champion lists can be combined with the other two techniques that we just saw.